Cementing is the process of mixing and displacing a cement slurry down the casing and up into the annular space behind the pipe. Once in place, the cementing is allowed to set, bonding the pipe to the formation. Oil field cement is made up of various compounds of calcium, oxygen, silicon, iron, and aluminum. The relative amounts of these compounds in the cement, as well as the fineness to which the material is ground, will determine its strength after setting, the rate at which its strength increases over time, its resistance to sulfates, and its setting time. The API has classified cements according to these properties, and choosing the proper class of cement for a given section of casing will depend upon the depth, and therefore the temperature at which setting will occur, the time allotted to mix and pump the slurry, and the strength required to withstand formation pressures and support the casing. Various chemical accelerators or retarders can be added to the slurry to speed up or slow down the setting time. Increasing temperatures reduce the time necessary for cement to set, so deep wells can become difficult as required pumping time increases while thickening time decreases. Retarders will usually be required to prevent premature setting of cement inside the casing. Other additives to cement include those also used for drilling fluids and are added for the same reasons. Bentonite for density reduction to avoid formation breakdown. Hematite or barite for density increase to offset high formation pressures. Lost circulation materials to prevent loss of cement into voids, and friction reducers. Friction reducers are added to permit the cement slurry to enter a state of turbulent flow at lower pumping rates and therefore at lower pumping pressures. This reduces equipment wear and horsepower requirements, as well as avoiding formation breakdown pressures. Turbulent flow is important to help promote complete mud displacement ahead of the cement, preventing the channeling of mud, which can lead to behind-pipe pressure communication.
Such mud channeling is the predominant cause of cementing failure, and much of a good cementing procedure is focused on preventing this from occurring.
Several techniques which are often combined are pipe centralization to allow uniform displacement of the mud by the cement, pipe movement, either reciprocation or rotation with scratchers to improve displacement in enlarged hole areas, and the high displacement rates and turbulent flow regime mentioned earlier. A good cementing procedure will also provide the following directions. First, condition the hole by reaming out tight spots. Condition the mud to remove cuttings and maintain a low viscosity. Install a guide shoe and float collar to prevent overdisplacement. Where appropriate, install scratchers to remove mud cake from permeable zones and install centralizers at appropriate intervals. Use a cement slurry as heavy or heavier than the drilling fluid to keep cement in place in the annulus. Be certain to select the correct classification of cement depending on hole conditions and strength requirements. Calculate slurry volumes using a caliper log and increase by an appropriate safety factor to avoid under-cementing. Pump plugs before and after the cement to ensure proper displacement. Maintain tension in the string while the cement sets. And remember to pressure test the cement job prior to drilling out or perforating.